audio, actually.
I am. Yeah, you guys are loud and clear.
Okay, it's good now. We're fine.
Okay, cool.
Okay, welcome everyone. This is a session of the DETNET working group at IETF 121. Lou Berger and myself, János Farkas, co-chair the group. And we have our secretary, Yves Schuler, with us in person in the first row. Many thanks for all the efforts. So as we are at the IETF, this is the Notewell. I guess you are familiar with it. If not, then please make yourself familiar with the rules and policies. This is a summary of rules and policies under which we conduct our meetings. I guess I would like to primarily remind you that everything what you say it becomes part of our permanent records and is a contribution to our work. This is the IETF conduct guidelines on how to behave to each other. So please respect each other and use courtesy to colleagues at all times. It is a professional meeting for impersonal discussions and stay technical. These are the meeting tips. On site, please don't forget to join either the on-site tool on your phone or the full client on your PC. And if you want to say something, please join the queue. That's the way we manage the contributions, the verbal contributions. So please queue up on-site as well. Thank you for joining remote. You have found yourself. I think nothing needs to be added on that part. Miteco, you know that we are at the Miteco. Blue sheet is automatic, so please join the tool. And I would like to highlight the note-taking part. It is joint note-taking. So please also join the note-taking. It's also link is also in the chat in the slide deck. Don't need to repeat what is on the slides, but the key thing is to capture the essence of the discussion. And also please double check if what you said is captured accurately. So this is the agenda. I'm not reading it out. You know where it is. And just a reminder on what we expect. So working group, authors of working group documents, please focus on the changes from the last meetings and what are your plans to complete the document. Of course, it applies to everyone to keep the schedule and the timing. And for non-working group documents, please focus on what part of our charter you are addressing with the draft. For any new drafts, please give us a summary and what you envision as next step with your document. This is a status update on the working group on our documents. Really good news that we have 2 RFCs published since the last IETF. We would like to thank all the contributors to get it done. So now the Yang data model is out and the third OM document is published as an RFC. We have requested publication for the raw technologies. So it's under the area directorate reviews. We've got comments and we are addressing comments on the list and moving on with it towards completion. And we have 2 documents that are at the status of working group last call. One of them is the raw architecture, for which it is the second last call. It was developed in the raw working group at the first place. The first last call was conducted in both groups, and now the raw working group has been merged to the DETNET working group. So this is the second last call. We get the detailed update from the editor during this session. And the other one is the control airplane framework. For this, this is the first working group last call, and we also get an update from the editor. There is no recently adopted document or no candidate at the moment for adoption. And we have a couple of documents that are not on the agenda at the moment, working group documents. One of them is the scaling requirements. The working group has been developing it. I guess nothing new to add at the moment. And the other one is the raw industrial requirement, which has not been progressed for now. And we have two working group documents that have that are at the expired status. The raw framework is kind of has been parked to get done with the architecture and to be picked up after we are done with the architecture. At least that's the plan. And there is the DETNET topology Yang, which has been discussed and not so much activity at the moment on that one. Okay, next.
Do we
Yes,
want-
please.
Go back. Do the authors or editors of the first two documents that are not on the agenda have any updates they can give us? Can't really see because of the lights. Okay, well, you'll talk about that at the end also.
Yes. Okay. So we have two slides now on liaison statements. It's been a bit more active part than usual for us. We have three boxes for liaison statements related to deterministic work items conducted in ITUT study group 13. The one on the top, we received, like us, DETNET working group, and actually the IEEE 2.1 working group as well, received the same liaison statement in April. And this was for information on the developments on their work items. And the 802.1 working group actually has responded. This is why they are in the same bigger black box. We were copied, that networking group was copied on it, and the response was for information. And the newest one is what we received during the summer after our last IETF from ITUT study group 13. And this is for action, not for information. So we are expected to respond. And this italic text has been copied from the liaison statement. Let me read that part out. It's a short sentence. Study group 13 would like to seek your feedback as to the above work items, in particular with regard to the relation to work conducted by IEEE and IETF, possible overlap with your work, and further opportunities for collaboration you see between our organizations. Do you have anything to add to these liaisons?
Hi, it's Rod Van Meter, Cairo University. Just a quick procedural question. Why do we have two of the same screen up here instead of one of the Meet Echo with the transcript? Did I miss something?
I'll ask Meet Echo in the chat. We don't control that.
Okay.
Just
usually,
while you're up there, if you
Yes.
haven't done so, well, you must have because you're in queue, but I'll
Yes.
take it as an opportunity. Please, people scan in. Clearly, there's a lot more people in the room than there are on Meet Echo or in the note taking. Please make sure to scan in either over there or at the mics, and then join us for note taking, please.
Great, thank you. So as for this liaison statement for action, the suggestion is to respond, and
Thank you, Meet Echo.
and as usual, we craft our responses on the list. So that is the suggestion from ourselves. An initial draft will be posted, I guess, quite soon. But before moving on, let me ask if anybody has anything to add or any questions on the study group 13. Liaisons. Nobody in the queue. Okay, the bottom one, the incoming one is from 5G ACIA. This is an industry forum, works on the application and deployment and so on of 5G in various verticals. And actually they have published a white paper on DETNET for 5G industrial use cases. This is a for information liaison, and again, I copied some part of it. This is for information, informs us that they have published this white paper, and this includes a summary of the DETNET working group efforts, actually. And they also suggest or identify potential progress for the standardization of the controller plane framework document. So my read of the last sentence, they would like to see the draft published. For this one, I would also suggest to respond, give them a status update where we are with the document, and thank for the incoming liaison. But I would like to also highlight that given that they given a summary of our work, if anybody reviews and have technical comments on something they did not get fully right, we can include that one as well. This is to be discussed also on the list, but I see somebody joined the queue.
No, they're out.
Oh, out. Okay. Okay, so this is the incoming one, and then moving on to the one topic where we are about to initiate. John, do you want to say something to the previous ones?
Yeah, just briefly. I mean, I glanced at that white paper, and if I remember right, it's a fairly large brick of a paper. So, if we hope to actually have somebody review it, it seems like just like with other large documents, we might, instead of just sort of passively saying, "Hey, if you feel like reviewing it, go ahead and send the notes," we might need to actually more actively solicit a volunteer. I don't know if it's important for us to have reviewed it, but just an observation. Thanks.
Sure. Thank you, John. Okay, the second slide on liaisons. This is what we are about to initiate, like send out, and this is related. We have two sub-bullets related, both of them to the road technologies draft, and this is based on a comment we have received from the Ops Area Directorate review, as road technologies draft refers to technologies of other SDOs, in particular IEEE 802 and TGPP. The suggestion is to send liaison statement to these groups to inform them about our document, and if they want to give us a feedback, they could. So, but make them aware that we refer to their technologies. As for the IEEE 802 part, 802.11 and 802.15, we have actually a coordination team between IETF and IEEE 802, regular meetings before every IETF, and we try to minimize exchange of liaison statements. So what's gonna be happening is that the 802 working groups will be informed via the working group chairs at the upcoming plenary session next week. And if they want to give us feedback, they are welcome. As for TGPP, we identified 4 working groups that we would send a liaison statement about our document. A draft liaison statement has been sent to the list last week, and or early last week, and there is no objection from the group. So the plan is to send it. Any questions, comments?
We should keep moving.
Okay, and moving on, reminder on IP disclosure procedures. It's very important to follow the procedures and disclose your RPRs. We have the regular RPR codes as usual. On the document status, we really ask status update on working documents at every IETF meeting. We just discussed that for our working group documents. And to progress our work, we would like to highlight that the main forum is the list, of course. That's where we build the consensus. We have the sessions at IETF meetings, but we have further possibilities. We can have interim meetings. If our contributors from the working group see the need, please reach to us chairs, and we can set up interim meetings and so on to progress our work. And the last slide in the
One last thing on that. We had a couple of, no, I'm sorry, one back. We had a couple of working group documents that didn't send in status nor requested a slot. In the future, we're going to put you on the agenda to give us status and keep asking you to give us status, because we need to hear every meeting what is going on with your document, what is your plan to complete it, what are your open issues. We don't want to have documents just sit in the group for a long time not making progress. So we really want to emphasize that, because if it goes meeting to meeting without any progress, we start getting complaints of, why are you chairs holding up things? Why are you not progressing? Why is this work not, why is the working group not functioning properly? So we really need you to give us status, let us know what the open issues are so we can push through those issues and complete the work. Thank you.
Thank you. And coming to the last slide, there is the work we have been conducting on data plane enhancements. We have the scaling requirements working group draft, and actually we have a working group document, the taxonomy document. We will get update on at this session. And there are a number of individual contributions as queuing solutions proposed to address these requirements. And we want to progress this work. We had design team meetings trying to reach progress and so on. And now that we have the taxonomy document, the idea is to use the working group document to make the progress. We have some key questions like how many do we want to progress and how do we choose? And the proposal from our side is to use the taxonomy document. There is a section on functional characterization in there already, and we could identify categories of the solutions that have been proposed. The definitions of these categories can be added to the taxonomy draft, and then the working group could select, for example, at most one solution per category, or the working group may choose not to select a solution for a particular category. So this is our suggestion, and we would like to highlight actually that the work is contribution driven. So we get comments, why is it so slow? It's contribution driven from working group members. Any questions, comments? So we wanted to save some time for discussion here. Okay, then let's move on to the next presentation. Toles, do you want to say something?
Sorry, and I didn't find the login tool. I'll do it. So I think it would be good to have a discussion about, how many, RFCs make sense to actually steer more interest in the industry. I mean, we have the different categories of something like informational, experimental standards, right? I'm all for having as much as possible only one standard for one thing that, so I think this proposal of doing this way comes from okay, we only need one standard for things that are not overlapping, right? So if different categories do different things, we need a different standard, but one is good enough. And I'm saying that may not necessarily be the best approach for the working group to steer more interest, especially when these things are so novel that, first people need to get more experience with them, but they would only buy into experience if it's an RFC. That's what we have experimental and informational, and maybe when we take those opportunities into account, we come to different conclusions what RFCs we want to work in.
So to be clear, the categories we're talking here are not types of what track of standards track or experimental. We're talking about classes, just making sure everyone is on the same page. I think we are. If the group decides we want to conduct several experiments, That's interesting, but we'd still like to be able to categorize the solutions. And so, we were going to talk about this more later when we're on the taxonomy document, but we really want to help tease out from the current functional categorization the different categories or classes of queuing solutions. And then we can start, once we get that, we can bin the solutions and then we can have the conversation. Certainly the point of one solution per category, that would be optimal. And we certainly will not do more than one standards track. That's always a bad thing when a group does more than one standards track solution for the same problem. And I'm being careful here of saying standards track, not experimental.
Isn't that how the internet works, or otherwise explain ISIS and OSPF?
Okay, next topic on the agenda is an update on the control airplane framework. Shasong, could you give us the update? We have no slides for this one. It's gonna be a verbal update. If you could come up, everybody sees you better, I suppose. Let's
Get blinded with us.
Yeah, this is Xue Song, and I just briefly introduced the progress of the DETNET controller plan framework. First, thanks working group to help move this work forward, and this document is in working group last call. And thanks Kieran for reviewing the document and give some useful comments. The comments coming from mainly three aspects. The first one, there is some explanation or clarification sentences maybe not suitable for publication, so we will remove it in the next version. And the second aspect is that there is no clear statement about whether the document covers some policy-related mechanisms like admission control and encryption. So maybe we will consider to add one or two sentences to make this clarified. And the third point is that Kieran mentioned that she think there should be some guidance about explicit protocol extension. We have responded in the main list that in our consideration, the specified protocol extension should be covered in other related working group like LSR or IDR. And also I have given some example about the existing document which tries to answer this kind of question, what kind of extension should be requested if we want to support functionalities defined in DETNET. So maybe this part there will be left for further work in the working group, or if working group still think more introduction should be ended, we will also consider it in our next version. And also, as Janusz just mentioned, that in the liaison, the DETNET controller plan framework also been mentioned, and we will speed up the work to make sure it can be published. Yeah, Pascal, do you have any question?
Hello, Sushang. This is Pascal Thubert. And, well, I just get a comment recently, very recently, that the things we are doing in the raw architecture might not be fully reflected in your document, meaning that we should talk and work a little bit together to make sure that we have alignment of features and descriptions between what we have in raw and what you have in the control plane framework. So that's just a to-do that's left for us to do.
Yeah, we can work together. And I want to mention that actually Carlos has give some contributions related to role, but maybe not fully covered what should be done in role in this controller plan framework. So we could work together to make it.
Yeah, the big thing being what we call the orientation function in the row, which really happens mostly in the device itself, to sort out between the possible routes, the ones that this device is going to use at this time. Okay. So that's the little piece that we need to discuss.
Okay, sure. So maybe I should seek further suggestion from the chair. Are we supposed to, cover the roles part in a new section, for example?
So we have two working group documents that are going through last call at the same
Yes,
time.
yeah.
It would not be good for us to try to push forward one that doesn't address any of the issues in the other.
Yes.
I would think that the IESG would send that back to us to fix it.
Okay.
So we don't want to, we don't want to have the documents not be aligned. I don't think he's talking about a lot of work.
Okay.
It's maybe a couple of paragraphs on it.
Just to cover the case.
Just to make sure, it may not even be that much.
Okay.
So also as shepherd of the document, I've started my shepherd review, and I have a number of, I think, they're important changes, they're editorial clarification. So we're definitely going to need another version to address the discussion, which by the way is still going on. Kieran has
Yeah.
a response that would be good to respond to.
Yes.
So I think we'll have another version, and we should make sure that the documents are well aligned.
Yeah, sure. We, the others, would like to work with Pascal and also the help of chairs. Yeah, that will be very,
Yeah, look to the list. I was trying to get it out before this meeting. I didn't do it. I have it on paper, unfortunately. I'm
Okay.
sorry. But that was actually going to be one of my comments as well, is we want to make sure it's aligned there.
yeah, yeah. I think as
But
you have,
to directly answer your question, I don't see the need for a dedicated new section for RAW. The idea is that the RAW architecture and RAW itself refers to the control plane functions, and what to make it sure that what we have in the control plane framework covers what we need to be covered for RAW. It's not new section, just
okay, okay. Yeah, I think that makes the work quite more clear. There won't be much change to the whole document, just to cover what we should cover. Yeah, okay? Yeah.
Carlos Bernardo, UC3. Just to fully echo what you said, Janos, I think we shouldn't do a separate section also, because that will, I mean, DETNET and RAW supposed to be the same thing, right? So if we start doing like separate sections, starting to be something like it's different, DETNET should be the superset of wireless and wire parts. So
Yes.
that's.
Yeah, I think that will be the method we work on the next version. Yeah.
I think once we've worked out the text, it will be clear whether it's its own section, a subsection, or just a few word changes in the existing.
Okay.
We can be hypothetical about it, but let's actually look at the text changes that are needed, and then we'll decide.
Sure, sure. Let's work together. Yeah. Yeah, I think that's it.
Okay.
Thanks.
Thank you. Next one, Pascal, please, for the RAW architecture.
No, perfect.
Okay, it's one slide.
It's one slide. So
So
yes, there is more to actually discuss than was written in the slides, but in that slide. Okay, so RAW, for those who are not attending the RAW piece, is all about improving reliability and availability in a DETNET network. And we have started that work because, as opposed to wires, there is a prominent cause of loss in wireless in the transmission itself. So wireless is kind of the reason why we have started that work, and reliability and availability is what the work has been on, as opposed to latency, right? We are not looking at timeliness, which is another aspect of DETNET. We are just looking at improving reliability and availability. And for that, what RAW has been about is looking at using as much diversity as the network can provide. And because there was wireless as part of the story, energy and spectrum, which come together, were also critical element in that architecture. So we've done the RAW architecture for the most piece at the RAW working group, which was a spin-off of DETNET. And now we are folding this back in DETNET. So the whole idea is this architecture here is an extension, an update of 86.555, the DETNET architecture. So what we are doing in the latest version to be published very soon is probably to improve. We've been doing that over multiple editions, but this one also is focused on that, improving the best integration possible between what we've done here and the existing 8655. So the diffs you'll find the next version to be published soon will be using more of the original drawings from 8655 to explain how what we do here integrates in the DETNET architecture. So the other aspect of the changes that we are looking at is we got from some of the work group last call reviews that the terminology was a bit hard to follow. And again, there was a possibility to better integrate the words we are using with the general DETNET work. And so if you look at terms in the current edition like RCPF, LCPF, they will be gone. Yes, they refer to the thing we need to talk with Sushang, but it's going to be CPF because it's everything which is like the controller plane is CPF. And the specific piece that RAW really needs named, because it talks a lot about it, is the piece that we call the orientation in the OODA loop that we are describing. And so this orientation, we'll probably be calling it, the orientation function, which is a part of the controller plane. It is a controller plane function. So that's why I just mentioned to Sushang that the piece, the text that we probably need to add, to clarify in the controller plane framework is about this orientation function. So basically, yes, you'll find very few changes in the next version. It's still very, very stable. The changes considering improving the reuse of features coming from the original architecture, so the integration is clearer to the reader, and a few changes of terminology. So that's pretty much it. I think the working group last call is not concluded yet, so you still have a chance to come with additional comments. I guess we'll publish the next version in a few days, so you might want to wait for the next version as well. It's your call.
Is it clear what the changes are that you're going to be making in the next version?
I tried to explain what they are. I don't know if it's clear for people what I just said, but basically a few names changed, mostly the RCPF, LCPF. The RCPF being part of the CPF will just be called CPF. It's routing CPF, the routing function in the CPF. That's what it's going to be called. And the orientation function that's part of the OODA loop in the device itself will be called orientation function, unless somebody has a better name.
I guess it might be good to summarize on the list when the new version is out. What are the changes?
Yeah.
Before I publish, after I publish?
Whichever you prefer.
I'd rather publish and point on
That's fine.
what the text is.
That's fine. But after, either before or after, just the summary of what the changes are.
And we're also changing a little bit the text to clarify that this is just a piece of the generic DETNET architecture that we are updating here. And that this piece is all about reliability and availability, not latency or timeliness.
Questions? Well, thank you for all the work and also keeping us ahead of schedule.
Thank you very much.
Gino?
Hello, everyone. I'm Gino. First, data plane enhancements taxonomy. So the summary, it was adapted as a working group draft on this year, early this year, in May, and it updated to the version 1 on July. In the update in July, a new reference topology called grid was added. Before that update, the document only focuses on the topology itself. I mean the taxonomy itself. So how the solution can be categorized. By the way, there are 6 categorization criteria: periodicity, network synchronization, and so on. And for example, for the periodicity categorization, a solution can be periodic or non-periodic. For the synchronization aspect, a solution can be phase synchronous, frequency synchronous, or asynchronous. So there are a lot of possibilities. So simply put, there can be 2 to the 6 categories overall. So it's quite a lot. So the chair's plan to select one solution per category, that we have to think more about it.
So we were not thinking of these categories.
I see.
We're thinking of categories that the working group agrees to that for which we want to find solutions. So I don't think it's going to be 2 to the 6th. I really hope it isn't, because that's an awful lot of documents and a lot of work. I think discussion with you and with the other authors, as well as the whole working group, will be really important to identify these categories.
Okay.
And maybe call them classes of solutions. Maybe that helps better. That helps.
Just to add on that, we on purpose distinguished between functional characteristics and categories, so it's not the same.
Okay, I understand. And if that was the working group's goal, I think we have to work a little bit more on the taxonomy part, clause 5. For example, 5.1 and 5.2, periodicity and synchronization issues can be considered together. And 5.4, work conserving or not, and 5.5, target transmission time, are somewhat related with each other. So these things can be considered together, then we can come up with more concise solutions. Okay, I'll work on it. Okay, go ahead, let's go ahead. The second update on this meeting is to add another reference topology called hierarchical ring mesh, which is specified in section 6.2. So I will focus mainly on that 6.2 in this talk.
You have to go back to you can't multitask.
Oh, yeah. So let me clarify what the definition of the reference topology. A reference topology consists of two things. One, network topology. It's an abstract locations of source, destination, and relay nodes, and their interconnections. That's a topology we are usually talking about. The second one is the flows characteristics. Also, there are two different characteristics. One is the required or requested specifications and the traffic specification. For RSpec, we include usually latency bound and jitter bound. For TSpec, we usually specify maximum burst size, average rate, and so on. So these all together as a component of reference topology. Why do we need such a reference topology? It is to evaluate the data plane solutions, how they perform in real networks. So evaluation is the key here. So we need to have a performance metric to demonstrate. The two things, I think it is mandatory. The first one is the E2 latency bound. The second one is the jitter bound. These are two mandatory performance metrics. And there are other optional metrics, such as the statistical performance. For example, average of the latency, or the average of the jitter, or more specifically, latency distribution itself. If it can be demonstrated, it will be very easy to understand how the solution works in real networks. And there are also scalability issue here to demonstrate, because we are dealing with large-scale networks, and scalability is the key requirements of our solutions. You can qualitatively, not quantitatively, evaluate our solutions based on those reference topologies, how they can scalable, how complex are their data plane solution, the automation control complexity, or the slot scheduling complexity, when there are dynamic flows join and leave. So I will focus on the second reference topology. It is motivated by many wide area network, including the brain network, which spans over the entire Deutschland. Basically, it has 9 backbone routers, as you can see, with mesh topology. And there are lots of regional routers connected to each backbone router. There are altogether 152 regional routers. So it is not an internet, but quite a large scale, I would say. So based on this kind of wide area network topology, we have the editors of the topology document devise the second reference topology called hierarchical ring mesh. Here, the flow types. Please remember that flow characteristics are part of the reference topology characteristic, okay? But flow types is reused in the first, reused from the first reference topology called grid. I will introduce them in brief. And there are core network, and there is a core network and multiple leaf networks. The core network is a mesh with 9 nodes, and a leaf network is a ring with 7 nodes. These are again, the flow specification used in the grid, the first reference topology, and reused here again. These 3 types of flows, audio, video, and command and control, are directly cited from the documents studying about the in-vehicle networks. So I think these specifications are very accurate, I would say. There are actually 2 different types of audio flows, as you can see. And there are different types of video flows, for example, for ADAS or just the vision. So these are 2 different video flows, but anyhow, they can be categorized into single video flows. And there are lots of command and control flows because it is an in-vehicle network. So these kind of characteristics are summarized in the table on the right. And the most stringent requirements are picked and selected as the flow characteristic. Yeah, you will know what I mean. There are maximum burst size, maximum packet length, and arrival rate, which are stringent. The most stringent one picked from the left table. And the same can be said to the required maximum latency. Note that they do not have jitter requirements in this study. And when there is no jitter requirements, it is considered that jitter can be as large as the maximum latency. Those are kind of common accepting sense. So these are the flow types. And from now on, I will briefly discuss about the reference topology itself, but it is quite lengthy. I will go fast. The key idea in the reference topology 2 is to define so-called flow set. There are, simply put, 7 audio, 7 videos, and 32 CNC flows in a flow set. And those flow sets share the same path from the source to destination. So these flows can be considered as a single control entity. However, they have different characteristics. However, so we define those flows as a flow set. The flow set's total arrival rate is over just 100 megabps. And the leaf network looks like a ring, but yeah, there is a source destination pair attached to each node. So there is one source to node 1 and one source to node 2 and so on. And we are observing here the flow set from node 1 that goes to 2, 3, 4, 5, 6, 7, and 0, and then go to core network. That is the blue flow set. That is our interest. That is of our interest. Similarly, the leaf network can serve as a destination network. In this case, the red flow set coming from the core network enters to the leaf network and then pass through node 1, 2, 3, 4, 5, 6, and then left the network from node 7 and so on. So this is the overall operation of the leaf network. the detail you can read on the right side, but I think I have explained almost everything. The one of the important thing here is that the link utilization is around 70%. So that's the, I think, the golden value for the utilization for evaluation of a network, how they perform in the kind of extremely loaded case. And core network looks like the reference topology 1 grid. Yeah, and it is very similar. And the links are unidirectional. And the flow pass through those core nodes with the unidirectional link. And one core network node can be connected to multiple leaf network groups. Yeah, so this is a little bit complicated part, but anyhow, there are lots of leaf network connected to a single core network. And here, the link between core network nodes are not specified. It is a design parameter. Similarly, the number of the network leaf network groups attached to core network is also a flexible design parameter. So the authors of the solutions can choose freely. However, there is one recommendation that the maximum link utilization is between 50 to 80%. So it is kind of highly utilized network. The leaf network and the core network, they are highly utilized. And we will see how a solution performs in such an environment. Yeah. The flow path in reference topology 2 looks like this. I won't go into every detail, but the red path in the lower picture of core network, the red path and green path is just two examples how the path is established. So I would like to emphasize that you can see there are lots of loops in the flow path. The loop creates the interactions between flows and increase the maximum burst. So that's the whole point. That's the reason why we choose to use the unidirectional link to create more and more loops. So that's the intention of the reference topology. So at this point, I would like to say to you that this is a very tough condition to meet the requirements. Yes. Yeah, these are the description of the reference topology 2 and the status of the taxonomy draft. The future plan, it is too early to say the future plan, but currently we would like to evaluate the solutions such as the end-to-end latency bound, jitter bound, latency distribution, and control plane complexity, such as automation control, when dynamic flows join and leave. If a solution is slot-based and it is periodic, then there is another configuration issues, so-called slot scheduling. There's another control plane complexity, I would say. And we have to come up with all the complex issues in their solutions, and we would like to evaluate all together. And as chairs suggested, with this evaluation result, the solution's strengths and weaknesses will be revealed, and then we can recommend some of the solutions. Thank you.
Do you mind going? Yeah, thank you. So I think the listing strengths and weaknesses, as well as recommendation, are great things to bring to the working group. But I don't believe they belong in the taxonomy document, or I should say we don't believe they belong in the taxonomy document. That would be a separate analysis work, and as a standalone document would be very good. And we do notice and appreciate that you've you'll take on the categorization work in this document.
Right.
But that would be a great additional contribution to the group, covering those last two bullets.
Okay.
So
I understand.
thank you for bringing that up. Just
okay,
it's a little bit more about procedure because it's out of scope of taxonomy.
Right, I understand. Because this taxonomy draft will be used for the future works as well.
Exactly.
The current solution should not be included in the main body of the draft.
Precisely. Thank you. You have two people in queue.
Hi, Rod Van Meter, Keio University. So just a minor comment. You answered a couple of questions I had while you were talking, so I don't need to ask those. But the figures that are in the draft right now, the ASCII art versions of this, the source and destination links on those are not labeled as bidirectional, but I presume they are bidirectional?
That's a good point. Actually, in these figures, source and destinations are omitted. I think it will be better in the future version to include those entities as well. And if the source and destinations are two different entities, then the flow of direction can be unidirectional. If source destination are combined device, then that direction can be bidirectional. I will include that. Thank you.
I'm looking at figure 1 in the ASCII art, and so sources are on the top and bottom, and destinations are on the left and right. So presumably those could be unidirectional links as appropriate.
So,
But then in the ring mesh topology, the links to the rings, are those actually bidirectional?
yeah, the figure 1 you are mentioning is about the reference topology 1.
Right.
Yeah, in that figure, the source and destinations are drawn. I mean, it is specified, but in reference topology 2, it is not specified in the figure. But my intention is to put source destination entity together to each node. For example, node 1, there is one device or one entity that also acts as source and device. Maybe you can discuss it later after I put those source device in the figure. In that case, if the device is combined, then the direction can be bidirectional.
Sure. Okay. Just also check the text around that, because the text does say that they're unidirectional, and I think some of these links are bidirectional. So just check on that.
What is unidirectional is the link between the relay nodes, between, for example, 1 and 2. These are unidirectional.
So may I suggest on that one to align with the RFC we have on DETNET flow and service information? Like that is
Okay,
very
thanks.
specific.
Thank you.
Kuan.
Chuan from ZT. I'm confused with the last slide about the suggestion of the data plane solutions. As the chair suggested just now, we will select the data plane solutions based on the functional categories, but there are 6 functional characteristics types in this draft, and in each functional characteristics type, it will be divided into several categories. Then functional types milers plus categories, there will be over 10 categories. So it would be better to clarify the categories for the queuing mechanisms. This is my suggestion.
So we agree that looking at the functional characteristics by themselves, just trying to evaluate on all of those would result in too many choices or too many options. And clearly we won't have solutions in all of them. What we're envisioning is maybe a new section that follows. I think it's currently in section 5 maybe or 4. And we're envisioning is a new section maybe we'll call them classes of queues, but we'll leave it to the authors and the working group to come up with the proposed wording. But we're looking for general categorization where we're looking for solutions. And we want the working group to come up with the set where we want to drive standards or drive solutions, and then start adopting in each of those. We were calling them categories. You can call them classes, whatever you want to, how you refer to them. They are certainly not functional characteristics, though. Think of them as groupings that make sense. As Janu was talking, he mentioned that it's going to make sense to combine some things. It was word conserving, and I don't remember the second part of that, but it's going to make sense to collapse. And we want the working group to come up with that collapsed list, add it to this document. It would be a new section, and then match the solutions that we have to that. I look forward to the solution analysis work as well, but again, don't think it belongs in this document.
Yeah, thank you. That makes
Yeah,
sense.
Kwan, thanks for the clarification. Technically speaking, there are currently 6 categories. And if each category has 2 different groups, then it is right. There are 2 to the 6 categories. But in some sense, those among those 6 categories, some can be combined. So the number of categories are reduced. And not all that 2 to the 6 possible categories is feasible solution. So there are only feasible solutions that fit into those categorization. I think I envision that around 10 at most. So I think we can work together to come up with those feasible category solutions or feasible categories of solution, and then we can have a clear view.
Honestly, I was hoping a lower number of categories than functional characteristics. But anyway, this is a discussion to be conducted among the next steps in the group.
Okay. Thank you.
Thank you.
Okay, Sebastian.
Hi, Sebastian Robic, Interdigital. Quick question about the flow sets. It's indeed a very valid approach. So just for me to understand, is that what you measured, or is that what you propose how to treat traffic? Before I'm asking what I wanted to ask.
The flow set, as you can see in this slide, it's a simple one. It's a set of different flows.
Yeah.
There are audio, video, and command and control flows, 3 different types of flows. And combine those different flow types together and make them travel through the same path.
Good. Yeah.
Then we can explain easier the flow sets of the flows paths and how they travel through.
Yeah.
So it's just a simple concept to illustrate the difficult, complex part of the.
Absolutely, I'm fully on your side. So just to maybe one thing, you also mentioned that a flow set has the same source and destination. Now, if the community has seen that if you have XR application that has audio, video, haptics, which haptics are put under the command and control of it, some of them may be processed somewhere else. So if we have a DETNET environment with a multipath, where certain like haptics go a different route and being processed somewhere else, where you at some point bring it back into the application offering service, the source and destination might not be the same for the flow set, just for consideration.
Right.
But indeed, I mean, it's a valid assumption. It's just it could be more complex.
Right. So what you suggest is more realistic, I admit. But as you can see, the reference topology 2 is very complicated topology. There are lots of nodes and tremendous number of flows. It is very hard to specify which flow goes from here to there.
Yes.
So it's just a convenient way to specify the flows. You can understand that way.
Of course. Yeah. Thank you.
Thank you.
And going back to a comment that Janos said, we have a service model that's been defined and captured in our Yang models. I think what you're suggesting may be outside of that and an interesting addition. So I'd ask you to take a look at what we've published in the Yang models and think about your service model addition and come with a proposal, because it's absolutely real world, very applicable, and may not be adequately covered.
Thank you. Okay, thank you. So I will start another presentation.
You do. I just want to make sure we have a nice clean break. Is there anything else? Anyone else have any questions on the taxonomy? We're transitioning from what has been working group documents now to individual documents. So definitely a transition into the solutions and alternate solutions.
Please go ahead.
Okay, thank you. So from now on, I will present about the individual draft, so-called C-score. So I will introduce briefly about the history of the C-score. It was included in another draft, so-called asynchronous DETNET framework. It has been here for about 4 years now. 1, 2, 3, maybe 5. And the C-score was one of the solutions that was included in that asynchronous DETNET framework. If you are interested, I recommend you to read that asynchronous DETNET framework as well. There are lots of interesting other solutions, and even a solution for jitter guarantee. So it is quite huge amount of work. By the way, let's come back to the C-score. So it has been separated to an independent draft. It has been started in June 23 and so on. So there has been a lot of intensive debates, discussions, and there are lots of revisions until 119 meeting. After that, it has been quite stable. Nothing is being changed a lot. So what is C-score? It's very complicated to say, but in short, it is a stateful solution in entrance node overflow, but it is stateless solution in core. So it solves the scalability issue very easily, I would say. Moreover, it has an explicit equation or the expression, mathematical expression for the end-to-end latency, as you can see in the bottom of the slide. I do not want to go into detail, but one thing I would like to say here is that we can control the end-to-end latency by controlling small r. Small r is the service rate allocated to that flow. So it has very flexible performance. In this presentation, I would like to mention about how C-score performs in 2 reference topology we just said. The first one is the grid. The second is the hierarchical ring mesh. Because I don't have much time, I will just go through the important part. The flows are 3 types, but here the flows are aggregated at the edge of the network. The aggregations of flows reflected as a flow here in this evaluation scenario. And we have simulated those topologies with those aggregate flows. The source generates the maximum burst as much as possible. It used so-called Markov on-off model, which transit randomly from on to off. So when on, it generates traffic very high rate, as much as it can. And off state, it idles and so on. And then there is a token bucket after that on-off model. So that the flow aggregate conforms to the traffic specification, maximum burst size, and the average arrival rate, and so on. Packets are of various sizes, and total 10 packets per flow are generated. This is the result. here, the service rates, some of the service rates of some of the flows are allocated flexibly. Allocated flexibly means the service rate is different from the arrival rate, and so that we can control the end-to-end latency bound. In this setup, the B flow, which is the aggregate of video flows, the end-to-end latency bound cannot be met. As you can see in the red letters, the service rate of B and C types are altered from their arrival rates, and theoretical end-to-end latency bound exceed the requirements. The requirements is what you can see here is 5, 10, and 5 millisecond, 10 millisecond, and 5 millisecond. So B type flow, the end-to-end latency bound exceed. And the figure on the right bottom here is the box plot. I presume you are familiar with the box plot. Okay, thank you. And yeah, you can see that the actual statistical characteristic of the flows are much better than what the theoretical end-to-end latency bound suggests. And this is the second simulation with the different reference topology, hierarchical ring mesh. Here, not the flow aggregates, but individual flows are used. And similarly, Markov on-off model and token buckets are used to make the flows characteristic conform to the requirements. The packages are of various sizes with the unit of 10 bytes, and total 1,000 packages are generated per flow. Considering the number of flows, you can see this is a huge simulation. It takes days. It takes days to run the simulation once. And as I have mentioned, the flow set includes 7 audio, 7 video, 32 CNC flows, and so on. And the core network's link capacity is set to 2 gigabps to make the utilization of the core network to become about 62%. The flows with the longest path are observed and then shown here. Because the maximum hop a flow goes through is 20. So it's a very big network. And the link capacity is intentionally low, intentionally set low. The 1 gigabps and 2 gigabps links are used. Usually, currently 10 gigabps is a common, so it's a very harsh environment. So the result is that the theoretical end-to-end latency bound is much, much better than the required maximum latency, which is specified with red figures, red letters. However, you can say that in a larger network, compared to the previous one, this is much larger, the latency distribution is much, much better than the latency bound. So for example, 0.75 quantiles of each flows is less than 1 millisecond. So we can say that the majority of the packets in a flow meet the end-to-end latency. Yeah, this is the simulation and the theoretical maximum bound performance of the C-score. And finally, the end-to-end jitter bound, because the C-score doesn't have a jitter control feature. So it has the same jitter bound with the latency bound. The jitter is the variations of the latency. So the latency bound also becomes the jitter bound. And there are two complexity issues, one for the data plane and one for the control plane. In short, the data plane complexity for C-score is that it requires a priority queue. a sorted queue. We have to sort the packets according to their finish time. So that's the main complexity issue. It is the main drawback of Syscore, I think. It requires about twice the cost of the making chips. For example, at the same cost, Syscore chip can run at 100 gigabps, while a simple FIFO chip can run at 200 gigabps. Because in order to sort the packet, you have to in-queue and de-queue at the same time. While in FIFO, you can in-queue at the end of the queue and then de-queue later separately, independently. So it is twice slow. I mean, half slow, whatever. So that's the main complexity. Other than that, the control plane complexity is very little. All we need is the admission control, the traditional admission control that checks if the maximum total service rate exceeds the link capacity. There are no more control plane complexity. Yeah, this can be, yeah, because time is over, I will stop here and you can read the discussion. Thank you.
Just a clarifying question on the prior slide. It's when you say the latency bound, you're saying the queuing latency bound, because obviously it's not the transmission latency bound.
What bound?
Queuing latency bound. It's not the it doesn't include transmission latency.
It does include. The latency, there are, as you have learned in our class, there are 4 different types of latency. Transmission, propagation, queuing, and processing inside the node.
Sure.
The most important thing we are talking about is queuing latency. But propagation and transmission latency has to be considered altogether. It is already included. Yes.
I guess I'll take it off the list, but I don't understand how the jitter bound would include, your maximum jitter bound would include the transmission latency, transmission and propagation latency.
Yeah,
I understand worst case latency, worst case queuing latency. That makes perfect sense to me. But I don't understand transmission and propagation being included.
I see. Because transmission and propagation delay is more like constant value.
Exactly.
I understand. Then I will step back. Jitter bound is smaller. Thank you. Thank you for your comment. Yeah.
We have 2 people in the queue. I think it should be quick. Shafu.
Hello, Jinu, thank you for the presentation. Can you turn to page P5? Yes.
This one?
Yes. In this table, the theoretical end-to-end bound, for example, the video flow, you mentioned that it exceeded the requirement. So I wonder how this one is calculated, because if I remember clearly, the B type of flow is composed of 10 individual flows, right? So the arrival rate that is used to calculate the finish time is the rate of the aggregated flow, or is the rate of the individual flow?
You mean the 100 megabps? I mean 160 megabps.
My means that because you calculated the theoretical end-to-end bound, the sales rate, used to calculate the end-to-end bound is.
I see. I see your point. I see your question. So there is 2 different things. First thing is the arrival rate. The second one is the service rate. The service rate can be larger than the arrival rate, and we can make our service rate freely only if it is larger than the arrival rate. The service rate is different from the arrival rate. That's the power of the Syscore. We can set the service rate freely as we want.
Okay, so I think it is better you clearly give the exact value of the sales rate to calculate the end-to-end bound
Right.
later. Yes. Thank you.
Thank you. Okay, thank you, everyone. Oh,
Yeah, Torles, if you can be super quick.
Why is it always me to have super quick? So what's the state of independent review of the mathematical model proving the deterministic latency in this here?
oh, the validation of the expression.
Yeah.
Yeah, it is proven by another researcher quite a long time ago.
Okay.
Can I suggest that you give him the response on the list, just
Okay.
because we've filled all your time and I don't want to take from Shafu.
Okay.
Would be great to
But
have that
it'd be
in the
good to
draft.
just put it on the list and then you can take a look at it.
Thank you. For your patience.
Okay, so, thank you, yes. Hello, I'm Sofu Pen from JT. In this presentation, we mainly focus on the evaluation of EDF and the TKF. So I combined them together to introduce them. Next, please. I'm not see the next page.
Sorry, can you repeat? I tried to give you slide control. It doesn't let me to do that. So which page?
I don't see the control button. Thank you.
It's not working, just say next, please.
Okay, thank you. So in this page, the authors have initiated discussions in 6-month WGN list for the data plan encoding topic. And no feedback received yet. The related data plan encoding proposals have been requested presentation in 6-month WG during IETF 121 and waiting for more comments. So the main updates in the new version contains on the basis of the heavyweight loading topology evaluated in the last version. The new version further evaluated the performance metrics of another lightweight loading topology, the grid reference topology defined in taxonomy document. Heavyweight loading means that every hop is a bottleneck link, while lightweight loading is not. Okay, we will provide the evaluation of the recently discussed Lumber's reference topology in the next version. Next, please.
So we are on slide 3, isn't it? What you want?
Okay, so this is a bit slowly to show the next page. So this figure shows the heavyweight loading case where the observed flow is computed by other 4 flows on each hop, and the computed flows may arrive simultaneously at the multiple incoming ports with the same starting time when measuring the respective residence time. And every hop is a bottleneck link, and every hop reaches the worst case latency. Next, please.
So we are on slide 4 already.
Okay, if the turn to next page. So the grid reference topology is a relatively lightweight loading case, where the computed flows arrive at a small number, for example, 2 or 3 of incoming ports, and only link 2, 3, and link 8, 7 are bottleneck links. In this topology, there are 3 types of flows: audio, video, and CC, each with different T-spec and R-spec. In general, audio and CC consume less bandwidth and expect low latency, while video consume more bandwidth and can tolerate large latency. Next, please.
Okay, page 5.
So video flow is a little elephant that 30 bug-to-bug package in a single burst. There may be some debate regarding necessary of policing on video flow. So this page try to observe the trade-off between burst latency and the service scale based on video example. Say link 2-3 below, which is expected to cover 10 audio, 60 video, 10 CC flows, in which 10 CC plus 10 audio plus 20 video from the incoming port connected to source 2 and get the bus B1, 40 video from incoming port connected to node 5 and get the bus B2. The size of B1 is almost 7 million bits, and the size of B2 is almost 14 million bits. Both B1 and B2 are eligible arrivals. So the resolved size is almost 7 million bits, introducing a maximum queuing delay of almost 7 milliseconds just for a single hop. This is independent of any queuing solutions. So the trade-off may be reduce the resolved size, for example, by policy of flow or reducing the admitted flows. And the policy function is common for all solutions according to DETNET architecture. Next, please. So this page is the evaluation of EDF. The delay levels are chosen based on the hop latency bound of each type of flow. For example, 700 microseconds for audio and CC, 1400 microseconds for video to meet the 5 milliseconds or 10 milliseconds end-to-end latency along the path with 7 hops. For simplicity, a unified delay resource pool is configured on each link with slightly increasing the loading and assuming that the number of each type of flows on each link reaches 60. A possible delay level resource table is as below. We can flexibly assign a delay level to a flow based on its R-spec instead of its consumed bandwidth. However, it should be noted that a more small bundle latency of each hop can be calculated based on the actual number that is less than the allowed number of the immediate flows on that hop. Next, please. So if the allowed number of admitted flows is not exceeded, the bounded latency of hop is just the delay level, such as 200 milliseconds for CC, and 700 milliseconds for audio, and 1100 milliseconds for video. And the jitter is is generally zero with the help of the delay deviation E. And however, if the end-to-end jitter including transmission to destination application side, it is determined by the transmission amount at the last hop that faces to the destination side. That may not enable latency compensation function. Next, please. So this page is the evaluation of a TQF. The attribution period length 5 milliseconds and the time slot length 100 microseconds are chosen based on the service bus interval and the maximum packet size of flows. One attribution period contains 1 round of CC, 4 round of audio, and 5 round of video bus. Possible time slot resource table is as below. The principle is assuring that offset between the incoming time slot and the reserved outgoing time slot is less than the hop latency bound of each type of flow. Next, please. So the bounded latency hop is carefully controlled equal to the offset between the incoming time slot and the outgoing time slot. In the above table, assuming that the first round of workflows arrive concurrently, that is about flow interleaving. Video packets will experience large offset 10 CC and audio packets. However, different hops may have different flow interleaving and corresponding offsets. And the end-to-end bounded latency is the sum of bounded latency per hop. And the jitter is generally 2 times slot length or 0 with the help of time deviation E. However, if the end-to-end jitter including the transmission to the destination application side, it is similar as the EDF evaluation. Next, please. So now there are 4 categories of the queuing mechanisms, if I remember clearly, summarized in the taxonomy document. The authors believe that the 2 of the EDF and the TGF may be the right direction for the DETNET enhanced data plane. and the content is basically matched. So we would like to request the WG adoption if possible. Any questions and comments are welcome. Thank you.
Questions, comments? Okay, nobody is in either queue, so then let's go to the next one.
Okay, wait the screen to show. Hello, it's Sophopeng from the city. This presentation we introducing the mechanism to control jitter caused by pollution in DETNET. Next, please.
I have now added.
Oh, okay, I see it. I see it. Thank you. I see it. So, firstly, let's review some background knowledge and understand the motivation of this mechanism. Can you see the page 2? Okay, thank you. RFC 2216 defines that pollution function differentiates total buckets in a flow which conform to a particular token bucket specification from those buckets reached mode. And RFC 8655 specifies that the rate limiting and shipping functions at the ingress of the domain must be applied. Since a conforming packet may experience 0% delay, while a non-conforming packet may experience non-0% delay, therefore, jitter occurs. Some flows that are extremely sensitive to jitter may not like it. The DETNET path can only provide bounded latency jitter of the path itself, so additional mechanism is necessary to control it. So this page gives the overview of the solution. The end-to-end delay requirement of the service flow equals to the path delay plus the edge-to-edge pollution delay budget. The edge-to-edge pollution delay budget equals to the end pollution delay plus the endpoint damping delay. The endpoint damping delay is carried in the packet used as the holding time imposed on the endpoint before the packet is delivered to the application destination. So how to set the edge-to-edge pollution delay budget for the DETNET flow? It can be configured according to the T-spec and the actual possible arrival pattern of the flow. It may reach the order of magnitude of service bus interval. For example, a DETNET flow has a service bus interval 100 microseconds and 3 packets P1, P2, P3 per service bus interval. An extremely case of non-conforming pattern may be that P1, P2, P3 arrived back-to-back. P3 has the largest pollution delay, which may be 2/3 of SBI, and can be used as edge-to-edge pollution delay budget. It may also be very small, even 0, based on something or configuration. For example, the application source control the flow rate to fully comply with T-spec, and the edge-to-edge pollution delay budget may be 0. Smaller value of edge-to-edge pollution delay budget is better in order to make room of DETNET path delay. So this page shows that the damping and endpoint will recover the original pattern. The original pattern that may be non-conforming is shaped and head-end to a shaped pattern. Then get a DETNET queues along the DETNET path, and finally recover it to original pattern based on the endpoint damping delay. For multiple domain case, there are 2 options to implement the pollution jitter control. An explicit indication in the packet should be provided for the selected option. One option is to implement the pollution jitter control at the entries and exit of each domain independently. Each domain entries should maintain edge-to-edge policy delay budget for the flow. Each domain contribute a separate edge-to-edge policy delay budget to the end-to-end delay. Another option is to implement the policy delay policy jitter control only at the ingress domain entries and the egress domain exit. Only a single edge-to-edge policy delay budget is contributed to the end-to-end delay. So for the encoding considerations, the endpoint damping delay value is independent of any specific queuing mechanisms. It may be carried in the in a new IPv6 option for DOH or a new ancillary data for MPLS MNA head or IPv6 routing head.
Okay, thanks.
So, thank you. Any questions, comments? Thank you.
Yes, we have Gino.
Thank you for the presentation. I would like to remind you, not the question, just to remind you that the very similar approach or similar, the solution have been addressed in the asynchronous deterministic network framework, which I have been presented since 2020. So please take a look and try to avoid any overlaps. Thank you.
Okay, thank you. I have a brief response. I think there's still some difference because if I understand correctly, the what's the name you mentioned the document? So the ADN is used to resolve the problem that that these are large jitter along the path and avoid jitter and for example and endpoint, right? However, the policy jitter in this document is introduced by policy, not by the queuing mechanism.
Yeah, I understand there are differences, but I still think there are lots of overlaps, and we can collaborate together to how to handle this issue in the future. Thank you.
Okay, thank you. That's good.
Okay, any further questions?
Yeah, any collaboration where we can reduce the number of solutions would be much appreciated. Thank you. Xiaofu, thanks for keeping us on time. Appreciate the contribution.
Okay. I'm Rubin Liu from H3C. Today I will introduce RCQF, Resilient Cycle Queue and Forwarding. RCQF is built upon CQF. Design improve capacity for the I can't see the screen.
You can't see the screen?
I cannot see it.
How about right here? Just
Okay.
turn this.
Thank you.
Sure.
It works.
It's
too far.
no problem.
Its design provide a capacity for the delivery of the end-to-end DETNET flow. RCQF extend the capacity of CQF and make it suitable for large scaling network. Flexible definition of parameters such as the number of queue length, and the cycle period, it more friendly to control resource plan, topology, and the traffic change. Dynamic load balance between queue achieve smooth output when the queue are uneven, provide sipping and the load balance effect. IETF first proposed the cycling level sipping scheme, which has high forwarding efficiency and resource utilization. We first introduced the scheduling circle. One schedule circle is made of many sectors. One sector is represent one cycle which can schedule the queue. All the circle made up a schedule circle. For example, if the schedule circle is divided into 8 parts, then there will be 8 cycles. If the width of a cycle is 10 microseconds, then one complete rotation of the schedule circle will be 80 microseconds. By increasing the number of queue and the sector, different follow can be mapped to different queue to better support greater. I think the picture, the PPT have changed. Yes.
Sometimes when uploading, it,
Yeah.
it converts, unfortunately.
IETF sharing process occur during the cycle scheduling period rather than during the queue entry period. For example, the threshold value can be set at 50% of the maximum capacity of a single cycle for the forwarding. When the threshold exceeds the sharing of schedule between adjacent queue is performance. By adjusting of and optimize the above the threshold such as sharing, forwarding, and the backwarding shifting, and the step size, it's a possibility to achieve queue shipping and the share between queues and the smooth output of a package, thereby improve overall forwarding efficiency and resource utilization. We know the schedule circle and the load balance between queues will bring more jitter in the transmission flows. We introduce the jet damper. Jet damper is described in the draft. The jitter reduction mechanism describe a competition mechanism designed to reduce end-to-end jitter and meet the requirement of application with the tiny bounded jitter. The competition mechanism can be part of IETF and could achieve on time. The draft detail is the below link. The senior test the deterministic performance on H3C road. Senior is a Chinese environment network innovation. It's a It's a large network project aimed to help research and develop in future network. We have senior have conduct 3 tests with different paths to see how well the deterministic flow work on the long distance with multi-node. With a mixture of variable size deterministic and fixed size non-deterministic traffic. Deterministic traffic had an average jitter about 10 microseconds, and the max jitter is 18 microseconds. While non-determinate traffic had about 90 average and max 110 microsecond. On the Nanjing path with overload, determined traffic so no packet lost with 10 microsecond average jet and 19.8 microsecond max jet. No determined traffic experienced packets lost and had more had 12 microsecond and max 85 millisecond max. That's all.
Okay, thank you
Thank
for
you,
the
I think so.
presentation. Questions, comments? Okay, then thank you.
Thank you.
Let's move on to the next last one actually. Sebastian, please.
Thank you. Right, so I'm Sebastian Robic. I'm presenting here a first version of a new draft with my honorable colleague Luis Contreras from Telefonica. And as a outline, I'm trying to keep it to 5 minutes to allow 5 minutes for any comments from your side. So just to set a scene why we're doing this, the draft is quite short in size. So the motivation essentially is that we know in a lot of applications if they're sending data out, we know most of them don't fit into a single IP packet. So you have a couple of IP packets carrying at some point what I'm referring to, or we're referring to as application data units. So think about like a long JSON file that fits into 1 or 2 or 3 IP packets. So there's an application data unit that fits into more than 1 packet. So this fragmentation is just a very natural way of, that takes place in networks, and we know that, that's how we get the data over on the other side, and it gets then concatenated back. Now, we say that this set of IP packets that carry a single application data unit, we refer or we define this as a data unit group. Now, we know that applications, in particular in the XR space, and also for network digital twins, we have a mix of requirements when it comes to what sort of data we are sharing there. So for example, XR, as we had before, we have audio, video, haptics, and all of this has to kind of be sent over together in a synchronized fashion to be consumed by, in this case, human beings, XR. If you look at monitoring data from digital twins or for network digital twinning, if you expose data, the algorithms that operate there, mainly in this case AI/ML, we see those models are quite sensitive if data comes in a let's say time domain that is quite different to how it was trained. So those algorithms have issues then when it comes to confidence levels. Now, we also know that in 5G, we have concepts of what they call PDU sets, a bit like a flow set, what we heard before. And they basically use the knowledge of a set of PDUs that the network essentially can operate in congestion scenarios to perhaps drop an entire set of PDUs or an entire set of packets within that define a single application data unit, mainly for the purpose of if you drop randomly, of course, you affect every single ADU. If you just drop an entire ADU, like if we talk about video, if you drop an iframe, okay, it will go on, the codec can recover. You might miss a couple of pixels, but the codec itself works. And the video is still, from a human perspective, so the quality of experience is still quite high. But we also know that PDU sets only work for RTP. So only RTP traffic carrying video allows in 5G to use this sort of behavior. So what we're basically saying is, well, okay, let's try to bring this in a layer down to have it for any IP communication. So what we're basically proposing in the draft here is an extension to an IPv6 header that we define a new TLV, and we essentially allow the knowledge of in a single application data unit being put into a couple of IP packets, that this is being signaled within a header across the path so that each DETNET router on the way could then perform pre-off behavior, for example. So what you see there is quite straightforward to understand, of course. So we see a identifier for data unit group. So we know if you have a long-lived session, like an IP communication for downloading a video or pushing a couple of JSON over the same IPv6 flow, you essentially can then tag the entire group that carries a single application data unit across a couple of IP packets. And you can then, of course, UAP sequence them, and we have a couple of flags to indicate, for example, it's the end of the group. You can set importance values. So sometimes let's say a haptic perhaps is more important than an iframe, or a full frame of video is more important than an iframe. So you have ways of playing around with some importance levels. We also have the ability to flag up if the upper layers on top of IP is a control plane packet. So for example, TCP, or like if you establish a TLS tunnel first before you're issuing the actual data. So to really flag up that this packet that you push there is a control plane. So quite important that this is really being treated and goes through. And then we also have, again, linking nicely to the previous presentations, the ability to indicate bursts within a data unit group. So all of this together, we essentially say, okay, so what can you then do with that in a DETNET router? So essentially, we have now the ability within the router to not only look at like an S label and all the individual packets that come in and try to put in different queues and perform pre-auth, but now have the same behavior, but over an entire data unit group. So for increased reliability, for example, we can say, okay, we might apply frame replication or different queuing techniques over the entire group. If you're aware that there's a burst coming, you're like, okay, I understand now what's going on. And you see those couple of packets all belong together, and you can treat them according to the group and not just individually. In case of congestion, well, the importance flag could be used to perhaps decide which one to drop. Of course, as the last resort, if you simply can't do any other meaningful means in a router, well, dropping is supposed to be the worst thing, but at least it's one of the options. And of course, also scheduling operations. So if you look at multipath behavior, replication behavior, so this is all now possible with this extension. Instead of individual packets again, you have everything in one additional TLV in an IPv6 header that you operate now over this knowledge without building it yourself somehow. And with that, I would like to thank you. As a small addition, so in the draft, there's also an implementation or known implementation section. We are implementing this in the EU projects Predict 6G. So we implement this using eBPF, and we want to trial this later on in a lab facility. Thank you.
Thomas.
Yeah, thank you very much. So the problem is that something like an IPv6 extension header needs to be standardized and needs to go through a 6-man working group who has no idea about QoS or anything else. So if you are experimenting with anything QoS, be it DETNET or outside of that, your only choice so far has been to abuse any other existing parts of the header. So it's really a big pain, right? You've got some DSCP values, which is not good enough. If IPv6, people have been misusing bits of the address to configure policies derived from that. So the one direction I was thinking of that would make sense is if you look up, there is an expired draft discussing can we figure out some, joint header that makes it easier to have experimentation with QoS and bring that to Sixman. So I started to collect a little bit the ideas, and maybe you want to join the effort. I never got enough cycles to basically say, well, not a discussion, but let's have a real proposal that, we can figure out. A lot of experiments could go into that without them having individually necessarily to be standardized. But of course, also, at some point in time, then the DETNET stuff wouldn't have to, work on a header for itself. So I think that's kind of a pragmatic idea maybe to get, because we've been doing these things in vendors as well, and it's been a pain of without a good header to make any, even experimental progress.
Yeah, thank you very much. This is great input. I mean, at the moment we are adding this to the next top header as an extension, and it's just, I mean, any Linux machine eats that without any issues. But indeed, as you said, it is a header extension to IP in the end. Absolutely, yeah.
Gino, please.
Thank you. Thank you for the nice presentation. I have a quick question. So the single DUG has the same priority. I mean, the package in the single DUG has the same priority. Does that priority becomes lower sometimes or get higher for some?
So
events?
that is up almost to the application to set, or however you actually make sure the setter is being written. I mean, the application itself, if you talk about HTTP, I mean, all the libraries you have, you just have an object where you say FQDN port and here's the payload. You have no way of configuring the lower layers, right? It's an interesting proposal you have to say within the DOG, changing the I flag while you're walking through the DOG packets. I mean, one could do that. Now the question is, I mean, if it's needed, what's the great advantage we have then within the router in order to perform pre-auth? Maybe you want to play them with that. Absolutely, you can do that.
The question I asked because I think, as far as I know, in that networking group, every packet is precious, and we pursue the extremely low loss ratio, and all we care is about the latency and jitter. So, so I think it is a little bit confusing to have different priorities among packets within the same flow. And how I am not sure how that concept matches to the networking group.
Get you. So yeah, okay, good one. So so I did not anticipate that the ID importance flag changes within the flow. For me, the flow, even though it has multiple DOGs inside, the I flag will be the same more or less there. But of course, an application could misuse this indeed. Absolutely. Yeah.
Lou. Okay. Do you mind going to the next slide?
Yes.
So which of these things are DETNET unique or unique to DETNET?
The pre-auth behavior.
Okay,
Yes.
so that's, if you tie it into pre-auth, sure. Other frame replication, maybe not, but everything else is general, correct?
Yeah.
So it would seem to me that if you were describing a general behavior, it belongs as in the IPv6 six-man group. And if they agree to either this approach or another approach to cover the same function of grouping packets, then come to us and talk about how to make pre-auth work.
Okay.
So I think you have and I think this is not too different than what Torlis said earlier. There's a lot of pieces here that are interesting, but I think most of it is not DETNET unique.
Okay.
And if we were going to pursue this, we'd be stepping into an area that really doesn't belong to us.
Yeah, good point. Yeah, I mean, I will take this on board. The actual DETNET behavior that you can then act upon, you having data unit groups, that is indeed something that is still a bit work in progress, but I fully take your point that, yeah.
Yeah, so let's build on the data plane behavior that others define,
Yeah.
as opposed to define our own.
Yeah.
Kwan?
Juan from ZT, please move to the first slide. Yes.
This one or the motivation?
Yes, this one.
Yeah.
I think my concern is related to the loop because I was so concerned about the requirements of the use case. You mentioned the two use cases, XR and the digital trims. They are not the scope of the RFC 8758, the use case RFC. So if we need to confirm, to clarify, this is the unique, the DETNET specific use cases. We need to first consider the use case for this is if they are the use case for DETNET. We are working a new individual draft for enhanced use cases for DETNET. So maybe we can discuss about the
Absolutely.
requirement first.
Thank you so much. Honestly,
Yeah.
I have to admit I was not aware about this one. So about all the use cases. So I will definitely have a look. And if there's more work, I'm more than happy to contribute. Absolutely.
Yeah.
Thank you.
Thank
Great
you.
point.
Yeah, Thomas Eckert. So on what, so in DETNET, what we've specified is that we've got very specific tuples in the forwarding plane that basically determine, which DETNET service instance, so to speak, which DETNET flow traffic belongs to. So if you take a video flow and want to split it up in multiple different ones, this is a mapping operation. So you could say this is a higher policy layer where you're looking at these things and then, well, we may not even have the right packet header at that point in time. So that actually is a question on how we map it then to DETNET, right? So at this point in time, it would require an extension to the DETNET architecture to say that, other fields in the packet header can identify, which DETNET instance it belongs to. And I think that's a much longer term thing than to say, well, we want to get these things in the packet header, or we actually manage to modify and create 5 IP flows or so for 5, let's say, different pre-auth classes, right, with different redundancy. So that's a different, angle on how to look at it.
Very interesting. Thank you.
For this one, I think the way forward is 6 minutes. That was the conclusion. And I want to reflect one sentence to what Kuan said, that actually we have a use case RFC, but it's not limiting. DETNET can be used in use cases that are not in the RFC. Just don't misunderstand that.
Yeah.
Sorry, were you addressing that? I didn't understand.
The point I got Kuan made was that DETNET can be used on the use cases listed in the RFC. No, DETNET can be used in whatever use cases.
Sure.
Okay.
All right, thank you very much.
Thank you so much. Cheers.
We have few minutes for open mic, 3 minutes for any discussion on any topic anyone wants to bring up.
So I was wondering, I really love the Bangkok experience from a couple of years back when we had a joint with the TSN. Have you checked the schedules if we have any opportunity ever again in the near future?
Yeah, we have started to think about that. Madrid, July is an opportunity. A Saturday in between is the candidate day, and we are not the only one. I mean, that is not the only group. So we have started the thinking, but we are open to proposals on good point on what topics could be of interest for a joint meeting between us, that networking group, and the IEEE 2.1 TSN task group.
Yeah. Well, I mean, I particularly felt that a lot of the interesting other standard body representatives back in Bangkok last time were rather clueless about IP and IETF stuff, right? When I asked twice, the answers were, oh, we're all doing TSN, kind of at least, in our SDO, in our industrial vertical SDO, but we're also told to do IP. So, I mean, if TSN, which you're also, going to, has more traction with other industry bodies, and they may need more education of IP, maybe even more fundamental than just DETNET, maybe that's a thing that the IETF would be interested in. Right.
Thank you. We have Charles in the queue. Charles.
Hi, Charles Eckel. I just wanted, in the interest of time, to close on this liaison statement that we want to send to 3GPP. You brought it up. I think it was discussed within the working group. Are we good to go? Should I go ahead and get that processed?
Yes, please. We
Okay.
are good to go. Good to go. Please
And
send
we'll
it.
send it as informational, just,
Yes.
okay.
Thank you.
Fantastic.
Thank you
All
very
right,
much.
Yeah, and thank you, Charles, for all the support on this. Really appreciate it.
Indeed. Thank you very much.
Okay, any other questions? Well, thank you very much for a very good session. We look forward to seeing you in Bangkok.
Thank you. Bye.